So we will discuss one first problem. So we want to prove that L by 2 minus L minus X is equal to L upon pi summation n equal to 1 to infinity sine of 2n pi x upon L into 1 upon n. So we want to prove this fact. So for that, let's plot the graph first of this function. So if I try to plot the graph, suppose here is my L by 2 and my function is defined in, say, defined on 0 to L. So my function looks like this. So I do have two options. Here is my L by 2 and here is my L. So I can take this whole as a range. So my L is 2C. I can take that and I can work with that, or I can extend the function backside to the backside and work with this. So I'm going for the second approach. You can discuss the first approach as a homework. You can do that. So here is my minus L by 2 and here is my minus L. So I will extend this as not even function. So this is my even function. So instead of even function, I will go for odd function. So then my odd function, for my odd function, it will look like this. So this is my odd function. So assume that this is my f of x. F of x is extended to minus L to L as an odd function. Why I am taking odd function? Because we want to express this function as sine terms. That's why I am considering only the odd terms, so odd coming terms, that is sine terms. So by definition, we have f of x as a naught by 2 plus summation n equal to 1 to infinity. Note that here's value of 2c is 2l, which implies my c is l. So this will be an cos of nx pi by l plus summation n equal to 1 to infinity bn sine nx pi by l. But we know that f of x is an odd function. So what we know about the odd function? A naught is 0 and all an's are 0 for all n. So every n is 0. So to calculate bn, so to calculate bn's, we'll write down the formula, which is 2 upon L integral 0 to L f of x sin nx dx, which is 2 upon L integral 0 to L. Our function is L by 2 minus x into sin nx dx. So this can be written as 2 upon L integral of first value, keeping the first value and taking the integral of second value, will be cos nx upon minus n minus differentiation of this value is plus minus 1. So minus minus will become plus. So plus sin nx upon minus n square in the range 0 to L. Notice that, sorry, we Well, we are doing with the arbitrary range, so that's why here it should be pi by L. Here again it should be pi by L, and this will be n pi by L, and again here n pi by L, again n pi by L whole square. Now putting the values, observe that again we have the same advantages for sign, so that's why this term will be 0. So it will be 2 upon pi L by 2 minus L is minus L by 2. If I put the value as L, it will be cos of n nx, sorry, cos of n pi. So cos of n pi into this value, which is L upon n pi with this negative sign. So this will be plus. So the next term, if I put the value 0, it will be L by 2, and this term, the term in the denominator, and cos 0 is 1. So this will cancel because of the reciprocal. So we are left with n upon n pi, L upon n pi into 1 plus. So here it should be a minus sign here because of the lower limit. So minus 1 with, it should be plus because of this minus sign. So because of that minus sign and lower limit minus sign, it will be plus, and this will be minus 1 power n. So this will be, notice that if n is odd, this will be 0, 0 if n is odd, and if n is even, it is 2L upon n pi if n is even. So write down it in the series. We have L by 2 minus x is equal to, we have a naught and b naught as 0. So taking out the constant term here, those are 2 upon pi to L upon pi summation n equal to 1 to infinity. Well, we need only the even terms, so that's why I will consider them as 1 upon 2n into sine of 2n pi x upon L. Here I am taking only the even terms. That's why this 2n is coming into the picture, and this 2 and this 2 will get cancelled. So we are remained with L upon pi in summation n equal to 1 to infinity 1 upon n sine 2n pi x upon L, which is our target. So this we want to prove. So this 1 upon n is coming in the front side. So we will discuss one next problem now.